you're implementing AI inside of your company, one common problem that you're going to see is AI data readiness. And actually, in a McKinsey report, this is one of the most cited problems. Here, they say that more than two-thirds of high-performing companies say data is the primary obstacle for enabling AI. Now, there's four things we're going to go over here. The first one actually starts even before development. This is the scoping phase. Now, because we have limited engineering resources, we might as well start on the high-priority use cases where we could re-leverage our data pipelines. See, if you're doing a use case that has a very, very unique data set and it's all on its own in its own island, if that use case messes up and maybe the ROI just wasn't there in what you were expecting, then you burned all of your resources for something that's not really fully re-leveraged. But a good rule of thumb here is to favor AI use cases where you could reuse some of those data foundations. The next here is what I would call preparation, but this is more of making sure that we can convert this data into a usable shape. And you may have seen an ERD before. And this is important when we look at multiple data sources or multiple different tables within a data set, because then we can see how everything is relating to each other. Now we look at how the different data sources connect. We're looking for things like keys, primary keys, and how could we join them and what the associations are between them. You may have heard of the term RAG, and this is the typical approach for looking at unstructured documents. But the biggest thing for unstructured data is just identifying what are the documents that you realistically need. Now, in typical unstructured data fashion, I mentioned RAG, so we chunked, we index it, and then we put it into a vector store. Now next is, how do we actually connect to this data? There's only really a couple of ways to actually connect to data sources. First is any API and connectors. So most cloud tools have some pre-built connector around it. Next is ETL or ELT pipelines. And here you extract it from the source, you transform it in any way consistent format that you would like to have, and then you load it into this new database that you might need. Now another way is change data capture. This is CDC, and this only moves what is changed. And lastly is like a real-time streaming. This is event level streaming. So something like Kafka or Kinesis or something along these lines, this will give you near real-time streaming. Now lastly here is the context layer of it. You could have all of the data in one uniform place. However, the AI doesn't know what to do with it. What do the headers mean? What do the columns mean? And how does it actually manipulate this data to get the outcomes that you need? Now, there's a lot of information that could go into this layer, but I'm just going to give you some examples here. I'll say the most common one is a business glossary or some sort of dictionary. This could be what those codes are, what those tables mean, or along those lines. Another one could be any sort of tribal knowledge or institutional knowledge that the end users just know about it. There's also metrics definitions, for instance, active customers versus non-active customers. What does that specifically mean? And so the AI can understand that. Now, one last thing I want to touch on here is just security in general, right? Being able to access, specific information on the data model level, or maybe some information at least on the context layer. All of these things also need to be added onto your security protocol as well here.